Hi everybody and welcome. Today we're going to be talking about our second type of transformations, and that is reflection. So first things first, let's define what is a reflection. So reflection is a transformation where each point is an equal distance on the opposite side of a given line or point, depending on the situation. So I think a pretty common example of this is, if you think about a reflection, they do it for like beautiful people. And they'll say that if you draw half of their face, if you kind of like fold over the piece of paper, the other half of their face is like exactly the same. So like if we look at the most beautiful thing in the world, Winnie, we have Winnie, and he's an exact reflection. He's perfectly symmetrical on both sides of this. So if there's an ear over here, there's an ear at exactly the same point over here. If there's an eye over here, there's another eye exactly the same distance away from the line over there. So the idea for this is basically that if you erase one side of Winnie, you can recreate it perfectly and easily by just redrawing everything that's on the other side. Again, a perfect reflection, or it's folding over that line. A second example of this as well is if you have a point, you can reflect over a point. So let's say that this red dot is, let's say like 2 to the left and 2 up. If you were to reflect it the same distance over a point, it'd be equal and opposite. So it would be 2 down and 2 to the right. And that would be the exact reflection of that red point. So again, you can flip something over a line, or you can just do the equal and opposite over a point. So those are the two different types of reflection. So over a line and over a point. Okay, so with that knowledge, there are a few different types of reflections that we are going to need to know how to do. And we'll take some time to go over each of them. So we'll kind of break it up into parts. That way we can have some practice with each of those pieces. So for the first part, we're going to do reflections over the origin. So this notation means that R is for reflection, and the subscript, or the small font that says origin, just means over the origin. And this is a point, because if we look at the graph, XY coordinate plane, the origin is in the center. So how do we do this? Well, reflection over an origin is we take a point, x comma y, and it translates to our new point of negative x comma negative y. So anything that we have, we just take its coordinates and we do the exact opposite. So for example, let's say we have a given point, maybe it's 5 comma 7. So our point is 5 comma 7. 5 is our x, 7 is our y. For our reflection, we need our negative x comma negative y. So we'll take 5, do the opposite, we'll take 7 and do the opposite, and that's our new point. So instead we'll go 5 to the left and 7 down. And that is our exact reflection across the origin. Again, equal and opposite distances there. So that is one example of a type of reflection. A second type of reflection, and this one is going to specify this time over a given line or axis. So we can do one over the line y equals x. So again, R for reflection, and then the subscript is for over the line y equals x. So again, draw our coordinate plane. The line y equals x starts off at the origin and goes up 1 and over 1. It has a slope of exactly 1. So this is the line in green, y equals x. That's what we're reflecting over. And the notation for this is we start off with our point px comma y, and we translate it to our new image of p is y comma x. So we take our x comma y and we basically do the exact opposite, put them in a different order. Same numbers, different order. So let's say we're looking at a point like 2 comma 4. Our x is 2 and our y is 4, and we are going to equally and oppositely reflect this over this line y equals x. So our first point, 2 comma 4, and the prime, or the new image of this point, is going to be y comma x based off of our rule. So we'll do 4 for y, and then 2 for x, just in the opposite order. So we'll go over 4, and then we'll go up 2. It'll be something about like there. That would be our p prime. And if we look at this, we want to measure these distances. Again, equal and opposite distance across that line, y equals x. So honestly, pretty similar to our rotation format, where we are taking x and y points and just following a rule for either rearranging them or changing their signs. Just the difference in this case is we are reflecting it either over a line or over a point. There are two other ones. We're going to pause here for this.